Hey, Specka Spartans. Today it's Thursday, March 19th, 2020, and we're going to continue our packet that we did yesterday when we went live. So we're going to actually pick off on page 16. So I'm going to read you the problem because you can't really see it, but you all have it in front of you. So again, the information comes from yesterday, which was Wednesday, March 18th, and today, which is Thursday, March 19th, 2020's packet. I'm on page 16, problem 18. It says Simone used 3 pears and 9 apples to make a fruit salad. What is the ratio of the number of pears to the number of apples in the fruit salad? Simplify the ratio. So what I'm going to do on my paper is I am going to annotate. So first of all, this is number 18, okay? And we're on page 16. I'm going to annotate 3 pears, and I'm going to annotate 9 apples. It's asking for the ratio of pears to apples. So the first thing that I got to do is I got to label pears to apples because a ratio is written in order. So we have pears over apples. When I look in the question, there are 3 pears, so 3 is pears, goes on the numerator, and 9 apples is the denominator. Now, when I look at the question that's on page 16, there's 4 answer choices. 3 over 9 or 3 nines or 3 colon 9 or 3 to 9 are not there. So what I need to do with this 3 ninths is I need to simplify the ratio by dividing. And how do I do that? I find out what the greatest common factor is, or greatest number I can divide 3 and 9 by, which is 3. I'm going to divide the numerator and the denominator by 3. And when I divide 3 by 3, I receive 1. So it's 1 pear. And 9 divided by 3 give me 3, which is 3 apples. Therefore, 1/3 is going to be answer choice A. So you're going to take 10 seconds to write this down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we're going to turn our attention now to page 17, which is going to be the question number 19. Let me erase this. And now let's look at what we got. So again, we're on page 17. Page 17, problem number 19. This question asks you, a bakery sells 5 apple muffins for every 2 bran muffins. Which table shows that ratio? So I know that I have 5 apples for 2 bran muffins. I need to figure out equivalent or equal ratios. So, if I double 5, I get 10. If I double 2, I get 4. If I double 5, 10, I count by 5, so I get 15. 2, 4, 6. 5, 10, 15, 20. 2, 4, 6, 8, and keep going, 25, 2, 4, 6, 8, now we have 10, 5, 10, 15, 20, 25, next is 30, 2, 4, 6, 8, 10, next is 12. I'm going to keep going until I get to 40 because on your multiple choice, the highest number they have there is 40. So let's keep going. We got 35. Keep adding 2, we get 14. And if we add another 5, we get 40 and 16. Now, here's the dilemma. I made my own ratio table, and I got to find out which ratio table matches the questions on the paper. So let's look at it. 5 and 2 are in choice A, but 10 and 12 are not, so it can't be A. Let's look at B. We have 10 apple and 4 bran. That's true. 15 apple and 6 bran. That's true. 35 apple and 14 bran. That's true. Therefore, choice B is the answer for page 17, question 19. We're going to now turn our attention to page 18. Page 18 is a unit rate question. So what I'm going to do is I'm going to erase the board. And now we're going to work on unit rate. So as you were shown yesterday, and also if you looked on Google Classroom, there are videos on how you find the unit rate. So let's read the question for page 18. So page 18, problem 20. It said, Alyssa rode her bicycle for 135 miles in 9 weeks. Eric rode his bicycle 102 miles in 6 weeks. Eric was 102 miles in 6 weeks. We need to figure out the unit rate of both of these and which statement is true. So our task is to find the unit rate and the statement that's true. Find unit rate. So we're going to do this. We're going to divide our paper into half, make our T-chart. On the left side of my paper, I'm going to use black because that's the question for Alyssa. Let's deal with Alyssa. It says Alyssa has 135 miles in 9 weeks. So I know that I'm comparing miles to weeks. Miles over weeks. All I'm going to do now is substitute the numbers where they go. So in the numerator, we have 135 in 9 weeks, which is the denominator. Now I'm going to divide 135 divided by 9. And hold on a second. When you divide 135 by 9, you're going to figure out how many miles per week she will ride her bicycle for. So now when you do the division of that, you are going to arrive at this as your answer. He will arrive at, hold on one second, hold on, let me see what I got here. We will arrive at 15 miles per week. So it's 15 miles for 1 week. That takes care of Alyssa. For Eric, it's 102 miles in 8 weeks. So we're going to write Eric on the right. We're going to write miles over weeks. He has 102 in 6 weeks, 102 divided by 6. When I do the division, I get 17 miles per 1 week. Because unit rate means division for 1. So now I ask myself, obviously, Eric rode more. He rode 17 miles, Alyssa rode 15. Which statement accurately matches? I got to find the difference. To find the difference, I subtract 17 from 15, and I arrive at 2. So choice A, which says that Eric rode 2 more miles than Alyssa. So Eric, 2 more miles. And that is how you find the unit rate. Take 10 seconds to write this down, and then we're going to move on to question 19. 21 on page 19. Okay, we're going to erase that now. Okay, now we're going to go to page 19 now. So, we're on page 19, number 21. Again, this is another unit rate question, but now you have a table where you got to find the missing values. So here's what we got. This is unit rate again, which is division. It says there are 35 minutes to fill 5 boxes. I need to figure out how many boxes I can fill in 1 minute. So I need to divide 35 by 5 to get my unit rate, which then is going to give me 7 minutes for 1 box. So on my table at the bottom, we have time and minutes. And then we have boxes filled. So I know that in one box will take me 7 minutes because that is my unit rate. And if I have 2 boxes, I'm going to double that or multiply by my unit rate of 7 to get 14. 3 boxes would give me 21 minutes to fill. 4 boxes would give me 28. And 5 boxes is going to give me 35 minutes. So that is how you would do page 19. Let's look at the extension now on page 20. I'm going to write it on the other side so those of you that are still writing can write it down. I'm going to give you another 10 seconds and I'm going to erase it. Here we go. Let's do page 20 now. The next problem. All right, let's look at what we got. We are now at page 20, number 1. It says, in 2010, Kim earned $17.50 for 2 hours. Determine the unit rate for how much money she makes per hour. So we're going to write, Kim makes $17.50 for 2 hours of work. I need to know if she works 1 hour, how much money will she make for every hour of work? So I asked myself, how do I get from 2 to 1? Obviously, I divide by 2, which means if I divide by 2 here, I have to divide by 2 on the top to figure out how much money she makes per hour, each hour, every hour. So look at what I'm going to do. I'm going to do it right here. $17.50 divided by 2. 2 doesn't go into 1, but goes into 17 8 times. Oops. 8 times 2 is 16. 1 brings down the 5. Bring up the decimal point. 2 goes into 15 7 times. This gives me a product of 14. The difference is 1. Bring down the 0. We now get 5. So this goes to tell me that she's going to make $8.75 for every hour. Now let me show you what this looks like in a ratio table for those of you that use that, because you could also use that. So I'm comparing cost, or actually I should say money, sorry. Money earned by the hours worked. Right? Those are my 2 labels. So now let's fill in. We have 1 hour that I work. I earn $8.75. In 2 hours of work, I make $17.50. So that is how much money she makes per hour, $8.75. Now, the next part says if she makes $175, right, how many hours of work is that? So I'm going to erase this part over here, and we're going to use what we have to figure this out. We already know that it's $8.75 for 1 hour. So I need to know if she earns $175, how many hours of work will she have? So the strategy we've been showing you is the butterfly method, cross multiply. Cross multiply. I'm going to make my little butterfly. Now, I have 175 times 1, which is $175. I'm going to divide that by 875 to figure out what the denominator has to equal. Now, I cannot have a decimal when I'm dividing, so I'm going to take the decimal to make it a whole number and move it 2 places. So now it becomes 875 here. 175 now becomes, the decimal point becomes to the second zero. I'm going to bring up the zero, the decimal point. So now I converted everything into a whole number because I can never divide by a decimal on the divisor, which is outside. 875 goes into 1, no. Goes into 7, no. Goes into 175, no. But goes into 1,752 times, because 2 times 875 is 1,750. This subtraction gives me 0. Bring down my 0. So now she has to work 20 hours to make $175. So the answer would be 20 hours. Okay, let's move on to the next part. Again, I'm not going to model every single page. I'm only going to model a few. Page 21 is very similar, so you can try that one on your own. But we're going to look at page 22, though, because that one I feel like you're going to need some assistance on, and I want to help you with that. Okay, so let's erase this now. Okay, now, again, you're going to complete page 21 after. Okay, here we go. Let's try page 22 now. Write the letter that matches the ratio on the line. So page 22, problem number 3. So I'm going to divide my board into 4 parts or 4 components. Like so. And you could do that at the bottom of your paper where it shows show all work. So you're going to divide it like that and put A, B, C, and D, which are the answer choices. A, C, B, and D. Okay, so now let's look at what we got. In the first one, it says $7.50 for 3 pounds. So I'm going to divide 3 on the outside by $7.50 on the inside. When I do the division, I get $2.50. That is my unit rate. So on the first line, for $7.50 for 3 pounds, I write choice C. It looks like this, $7.50 for 3, I write a C. Let's look at the next one. If I have $3.75 for 5 pounds, I need to figure out the unit rate. So I'm going to divide $3.75 by 5. And when I do the division, I arrive at 75 cents per pound. Right? This gives me 2, bring down here, 5 times 5, 25. We now get 75 cents. So on the second one, where it says $3 and what is it? $3.75 for 5. I'm going to put an A. Let's look at the next one. We have $6 divided by 4, and we arrive at $1.50, folks. So on the next one underneath, you're going to put a letter D, because for $6 for 4 pounds, each pound is $1.50, which means obviously the last one is B, which was $13.50 for 6 pounds, and I'll show you why that's true now. So 6 into $13.50. When I do the division, I get $2.25. 1, bring down the 5, bring up the decimal, 2, 12, this is 3, bring down the 0, this is 5. $2.25, therefore it's choice B. So it reads C-A-D-B with the work shown. I'm going to erase this now and move on to page 23. And then I'm going to go on to the next lesson. So we're going to go now to page 23, and then you will complete the rest of it on your own. Okay, last problem. Here we go. All right, this one is page 23 now, problem 4. Page 23, number 4. This one's about equivalent or equal ratio. So here's what it reads. It looks like this. It has a page with the carrots, okay? And it says this. It says, 1 batch of vegetable soup uses 2 cups of chopped onions, 1.5 cups of chopped celery, and 1 cup of chopped carrots. Select the ratio that will help each chef compare the number of chopped carrots to the number of chopped vegetables. Circle all that apply. Hint, there is more than one answer. So what we're going to do here is we're going to make a table. We know that we have to compare carrots to the total number. We know that in the question, there is 1 cup of carrot, and to find the total, I'm going to add up all the cups that there are. So we're going to write the word total here. We're going to add 2.0 is the same as 0. We're going to add, the 2 represents the onions. The 1.5 cups represents the onion. The 2 cups represents the onions. The 1.5 cups represents the celery. And the 1 cup represents the carrots. So the total means I have to add them all up. And I get 4.5 cups. So this is 4.5 cups for 1 carrot. Now, to find equivalent ratios, I'm going to figure out the pattern. I'm going to double the numbers. So if I double 1, I now stop at 2, right? 1 times 2 gives me 2, which means I have to multiply the bottom by 2, which gives me 9. So 2 9ths is equivalent as well. Let's move on to the next one. 3. 1 times 3 is 3. And 4.5 or 4.5 times 3, if I add another 9 plus 4 is 13 plus 5. Let's move on to the next one. If we have, for argument's sake, let's say that we have 4. 1 times 4 is 4. Therefore, 4.5 times 4, well, 13 plus 4 is 17. And a half is 1. So 17 plus 1 is 18. So now we know that 1/4 is equivalent to 2 9ths, which is equivalent to 3 over 13.5, which is equivalent to 4 over 18. Therefore, we're going to pick choice B, which is 2 9ths, and we're going to pick choice D, which is 4/18. That will be the last one that I will model for you. And you are going to complete, actually, I'm going to model one more for you. I'm actually going to model for you page 28 for you, and you will complete the other pages at your own leisure. So I will model page 28 for you, and then you will be on your own to complete the rest and fill out the exit ticket we have provided. Erase that now. Again, if you have any questions, please feel free to send us a chat message to Mr. Rezerai, and we will be more than happy to get back to you. All right, so again, like I said, we skipped some pages. The pages that we did not do, you are responsible to complete at your own time. Last page. Page 28, number 10. Okay, this one's really interesting because this relates to the real world like all of them, like the one we just did about cooking as a chef. But this one's important because when you take transportation like a bus, a train, or a subway, right, there's a schedule. And the bus, the train, or the subway come every X amount of minutes. So this one relates to the real world. Bus A. And then we have bus B. It says bus A arrives every 75 minutes. MINS is minutes. And bus B arrives every 15 minutes, MINS minutes. They want to know when will they be together at the same time. So when will both bus A and B be on the track, be at the same bus stop, all right? The same time. So here's what we need to know. We know we're not going to find the greatest common factor because that doesn't make sense because each and every means you find the LCM, which are the multiples, which means each, every, least. So now I'm going to list all the multiples of 75 on my T-chart. So we're going to start here. We have 75. I'm going to count by 75. 75 times 1, 75 times 2, times 3 is 225. Another 75 gives me 300. Now I need to figure out when will bus B move if I do the LCM. And bus B was 15. So I am going to skip count by 15s. So 15 times 1 is 15. 15 times 2, 30, times 3, 45, times 4, 60. Times 5, 75. Times, the next one, if I add another 15, would be 90. Another 15, 105, and another 15, 120. So now let's look at what we got. We have to find out what's in common. They both share 75. But that 75 minutes now has to be converted into time. There are 60 minutes in an hour. So I'm going to write that down. 60 minutes is equal to 1 hour. So I know that my LCM is in the next 75 minutes. Both bus A and B will be together, but let's convert that into time. In 60 minutes, if it's 6 o'clock now, in 1 more hour, it will be 7 o'clock. So from 6 to 7 a.m., you have 1 hour, which is 60 minutes. So that's 7 o'clock. That represents 60 minutes. And I need to add another 15 to the 7. And now I will arrive at 7:15 a.m., which is now going to be choice B as in boy. Please make sure to complete the exit ticket on Google Classroom. And please make sure to complete the remainder of this packet using the examples provided to you both yesterday, which was on Wednesday, March 18th, and today on Thursday, March 19th. Thank you.